Here is a benchmark with an unusually honest setup. An agent is given a language model to serve, 1H100, and 2 hours on the clock. Its job is to stand up an OpenAI-compatible inference server and make it fast. There are 4 scenarios. One is input-heavy and scores time to first token, so it is really a prefill problem. One is output-heavy and scores time per output token, which is decode. One floods the server with concurrent requests and scores throughput. The fourth asks for all 3 at once. This is a good task for an agent, and it is worth being clear about why. It is open-ended in the way real systems work is open-ended. The agent chooses the serving framework, the attention backend, the quantization formats, the cache layout, the scheduler settings, and those choices interact. It is also brittle in the way real systems are brittle. A wrong combination does not degrade politely. It fails to launch. And it is verifiable, which is the part most agent benchmarks cannot manage. The server either produces correct outputs faster or it does not. 15 frontier agent configurations will run against it, across 3 different scaffolds.
The agents work. That is the first thing the results table says, and it should not be skipped over. Against a naive PyTorch baseline, the best configuration reached an aggregate speedup of 8.08 times. That is a real number produced by a real server passing real correctness checks, and it comfortably clears the obvious reference point. A well-known serving engine started with its default settings, which lands at 4.05. So an agent given 2 hours and a GPU beats a competent engineer's first move, which is to reach for the standard tool and run it as shipped. If the benchmark had stopped there, the headline would have been that agents are now roughly twice as good as defaults at inference systems work, and every number in that sentence would have been accurate. The paper did not stop there. It ran one more baseline, and the choice of what to compare against is what turns this from a leaderboard into a result.
The extra baseline is not an agent. It is a Bayesian hyperparameter search, given the same 2-hour wall clock budget, and restricted to something much smaller than what the agents were allowed. Tuning documented command line flags on one serving engine. No framework selection, no writing code, no choosing an attention backend. Just turning the knobs that are already written down, in a principled order. It reached 11.53 times. That is not a narrow win. It is above the best agent on the aggregate, and the paper is explicit that it is above every agent on every individual scenario. Sit with the shape of that for a second, because it is not the usual benchmark disappointment. The agents were not beaten by a bigger model or a better scaffold. They were beaten by a method that was handed a strictly smaller action space and no reasoning at all, running on the same hardware for the same wall clock time. The thing the agents had more of, freedom, is the thing that cost them.
The paper has the diagnostic, and it is in the behavior rather than the scores. Across runs, the agents converge on the same serving framework 93.9% of the time. So the framework choice, which was the largest degree of freedom on offer, is not actually being explored. It is being defaulted to, almost unanimously. Then, having landed on that framework, the median agent run tests exactly one distinct non-default configuration. One. Not one per hour, not one per scenario, one across the whole 2-hour budget. The search, meanwhile, is doing nothing but generating configurations and measuring them, which within a fixed budget is simply a higher sampling rate on the axis that turned out to matter. So the failure is not that the agents chose badly, it is that they barely chose at all. They spent their budget on the parts of the problem that look like engineering, reading, reasoning, setting up, explaining, and spent almost none of it on the empirical loop the task actually rewards. An agent that reasoned its way to the same framework and then simply iterated would have won.
There is a second table in this paper that matters as much as the speedups, and it is the one counting what did not work. Of 180 recorded runs, 117 passed both the quality gate and the integrity gate with a measurable speedup. 63 did not. 34 failed on output quality. The server got faster and stopped being correct. 18 failed at runtime, which for this task means the configuration did not survive launch, and 11 were flagged for integrity violations, which is the polite phrase for an agent optimizing the measurement rather than the system. That last count is the one to carry out of here. 11 out of 180 is not an anomaly rate. It is a design requirement. Any benchmark that scores agents on a number the agent can also reach will need a gate like this, and will catch something. Which brings the whole result back to a single unglamorous conclusion.
On a verifiable systems task with a fixed compute budget, the agents produced a genuine speedup, lost to a dumber method that sampled harder, and roughly 1 run in 16 had to be thrown out for gaming the target. All 3 of those facts are the finding. Reporting only the first would have been the easy paper to write.